So in addition to the usual complement of maintenance work that the crew has been engaged in pretty heavily this week, they're always participating in the multitude of science experiments taking place on board the station. One of these ongoing goals of the overall science research taking place on board the ISS is to help assess how crew members can better overcome the negative effects of weightlessness as they spend about 6 months 5 to 6 months in this weightless environment can have a pretty big impact on their body, specifically through the loss of bone and muscle mass. A little bit later this week, the crew is scheduled to start working with a new experiment from the Japanese Aerospace Exploration Agency called hybrid training, which is looking to test a new exercise protocol that could hopefully help crew members on board the station, as well as crews on future exploration missions, as well as also having some pretty big implications potentially down here on the ground. So to speak about this study a little bit earlier this week, I was able to talk with Dr. Masaki Shirakawa, the manager for Space Station Life Science Mission Integration at JAXA's Space Environment Utilization Center in Tokyo. And I started off just asking him to explain what's new about this hybrid training protocol and what the crew members are going to be doing to actively participate in it.
So the current muscle training device on board ISS, such as ARED, is very large. On the other hand, the hybrid training system is so compact that it can be used as a backup system for conventional resistive training device in ISS. And in the current experiment plan, a crew member will conduct the training 3 times per week for 4 weeks. That is total 12 times using the hybrid training system. And each training time is about 20 minutes or so. And after the series of training is completed, effect of the training or muscle function will be measured on board and on the ground after return.
Okay, and you make mention, the hybrid training system, it's very small, it's compact. What exactly is it, and what is it doing to, stimulate the muscles of these astronauts while they're in microgravity?
Yes. When electrical stimulation is applied to a muscle, the muscle contraction will occur, and this will generate force. On the ground, this force has a similar effect to that produced by weight. So against this force, if you intentionally bend or stretch out your arm, this muscle will be strengthened. So in the other words, the force produced by weight on the ground is replaced by that generated by electrical stimulation.
So I know electrical stimulation is used sometimes here on the ground in medical treatments and various physical therapies. Is it going to be kind of similar to that same mechanism?
Yes. As for electrical stimulation, we need to care the position of muscle to apply stimulus. If the position of the electrode is not good, it will not be an effective training. For the crew member, the position of the electrode is determined at the baseline data collection session before the flight, and it indicated by the supporter on orbit. And also the intensity of the stimulus is also important. So for crew training, both intensity and position will be selected for right value.
Okay, and so this stuff taking place on the station this week and continuing on is kind of the trial runs of this hybrid training. And you made mention that the device is very small, how might hybrid training be beneficial to future astronaut crews on long missions going way beyond Earth orbit?
Yes, the hybrid training system is so compact that the crew member can use the system even in a spaceship toward exploration. In addition, the investigators team has studied doing hybrid training as a resistive exercise while doing aerobic exercise, like a bicycle training. So we expect that crew can conduct effective exercise with short exercise time in total.
I'm sure it's a lot easier to carry that out into space than a big stationary bike. So one final question for you. What are some of the potential benefits that you guys are maybe hoping to learn that could be applicable to people down here on the ground on planet Earth?
Yes. Actually, the investigators team has already applied the hybrid training method to patients who need rehabilitation or who can't move just after surgery. And the astronauts will suffer from rapid muscle atrophy during space flight. So if effectiveness of the hybrid training for astronauts is showed in this experiment, we may be able to accelerate application of the hybrid training system on the ground. And consequently, I think we can demonstrate the human research in space is beneficial for people on Earth.
We always get excited when something taking place on space can help those just right back down here on the ground. Well, again, thank you for your time, Dr. Shirakawa. Best of luck to you and the investigation team in this ongoing study. We'll be sure to follow along closely. Thanks again.
Thank you.